Welcome back to another show and tell video. Today we're looking at a now vintage uh, kind of a desk tool measuring device. It's actually a proportional scale, and this one is set up in rotary form, and it's kind of evolution from, let's say, slide rule calculations, and then now with electronics we can just simply do formula calculations in programmable calculators, or just through basic arithmetic and algebra to come up with ratios for scaling objects. So if we were to, say, pick a real life example, I just happen to pick a random project that's been on the back burner. So let's say I'm building a scale model. In this case, I just happen to pick a classic M977 HEMTT, one of the 10-ton multi-axle, multi-drive vehicles, and I pulled out the instructions. And let's say I want to scratch build some extra parts to super detail the model, and here I have not only the pieces themselves to go off of, but let's say a fairly accurate side profile to give me a non-distorted, non-parallax starting point to get measurements from. And let's say I do know the dimensions of the vehicle itself, the dimensions of the parts of the scale model, as well as the dimensions of the diagram. Through these three sets of dimensions, I can get a pretty accurate set of dimensions to do a scalar set, and therefore be able to take any real life objects and measurements that I want to scale up or down, and therefore based on actual proportions against the three sets, I can actually then take any object and adjust it to the scale that would be appropriate to add to, say, the model. So since this is a 1:35 scale, so meaning, for example, 1 foot on the real life truck would actually be 35 times smaller on the model itself. Therefore, as we look at, say, a tire, this is obviously not real life size, but if you were to multiply the diameter of this tire 35 times, you would have a real life size tire. So let's say I wanted to add, for simplest definition, some sort of tool to the side, and I already know the dimensions to be, let's say, to make this easy, since this is 35th scale, 35 inches. So already we should assume through simple math that it would be 1 inch long on the model itself. But just to play along with the scale and how we'll use, let's look at the instructions real quick. And this one just happens to be made by the C-THRU ruler company. And this one has a little bit of contact info at the bottom, instructions, nothing on the back side, and you can see it's actually just a bunch of printed rulings around both perimeters of the discs that are attached along a common center point axis. So instructions say to find new proportional size, line up both present dimensions on inner and outer scales, one above the other. The new dimensions will line up automatically in the same relative position. Next, to find percent of enlargement or reduction, line up present size on inner scale under new size on the outer scale. So that's your inner scale here, and this is your outer scale here. Percentage will appear in the window opening. Here's your window right there. So if you look at all the rulings on the outside, here would be, say, size of original, reproduction size, and around the window, number of times of reduction, which would line up along this bottom center point here in the window, and the percentage of original size would be at the center point of the top of the window. So if I were to dial up, the measurements of our hypothetical tool that we want to add and scale down, and we know it's already 35 inches long, that would be the size of the original. So we can see this goes from 1 inch through a scale all the way around up to I believe 100 inches up there, and you can see how it's gradually expanding as it goes around. So 35 inches, and we want to bring it down to reproduction size of 1 inch. So 1 in 35, and then any other object that we actually wanted to scale that's some odd, how about that, making up words, to convert, then we could actually just apply this equation here. So this actually would be about, I believe, 2.85%. I did cheat and look it up on a calculator because I've actually used this conversion factor a lot in making parts. But that would be your equation there. Well, let's say you're in 48th scale. Then you would actually dial it around from the 1 to your 48 position right there. And then it would also give you the numbers along there for your reduction. So I'm just going to apply even up to 72 scale, but not 144. So at that point you would have to do a little bit of juggling of the numbers for the really tiny models. But at that point, I'm not sure how much scratch building of parts you would be doing on a scale model really that small, unless it was more of like a ship per se. But then you're also modeling meters down to almost size in millimeters. So you're still losing a lot of detail anyways. What seems to be small detail on a ship would actually be quite large in reality. Things like railings, the mesh on antenna, that sort of thing. Things that are photo etch parts, etc. It's been another show and tell video. Feel free to check out other videos on the channel. We also do unboxing videos as well as a selection of book review, media reviews. Feel free to check all those out. Feel free to like and subscribe. Thanks for watching. See you next time.